Hello, and welcome to another session on data mining. Today, what we are going to do is a demonstration of linear discriminants. And for that, we are going to need different colored markers. So I welcome you to get some markers with you, also some pieces of paper, and yeah, scissors, and something to draw straight lines with. And for that, I'm going to use this selenite crystal that I have lying around in my office. So we're going to use that to draw some straight lines, right? So we've talked about perceptrons, right? So a perceptron is a line determines a line. It's an algorithm for determining a line that separates points using a linear discriminant. Okay, so let's take a piece of paper. Let's make some points on top of it. Let's make some O's and X's. Okay, so let's think of this data set. Okay, the objective of perceptron, and as you can well see, this data set is linearly separable. So the objective of perceptron is then to find that line. And if you can think of it like this, what we are doing is we are using, let's say, the selenite crystal, and think of it like we have different solutions. Let's say this is one solution, this one, and it's not a good solution because it doesn't separate the two classes that we have. So for a given line, we determine how much error it produces, and then we try to move the line just like this one until we find a solution that separates the two classes. That's like the one over here, as you can see on your screens. So you can say that if you move this selenite crystal from here, it will keep on moving and it will produce some errors. And as we keep on moving, those errors are going to either increase or decrease. And what we want to do is to solve the optimization problem that lies at the heart of this classification problem. As we want to find the line, or we want to place this line such that we get a minimum error line, right? So that can be this line over here. Now this line separates these two classes, the circles from the crosses, and we get a perceptron. Let me draw that line for you. If you do that, we can get something like this one. I've already pre-drawn one, but you're welcome to try it yourself. And this is a line that can be determined using a perceptron. And if we have this axis labeled over here, and we know what the grid system is or what the coordinate system is, we should be able to recover the equation of this line. Well, this is very simple. It's simply in 2D, right? And but we've also talked about the limitations of perceptrons. And one of the limitations of perceptrons is that they don't give us the optimal line. The margin of the line that they give is not optimal. That means a small change in the input can change the label of the or the output of the machine learning model that we have. The margin for error of perceptrons is very small because they give us an arbitrary line, not the line that we want. And to do that, we've talked about how support vector machines are a better way of doing that. And they maximize the margin between the two classes, and thus a small change in the input does not have that big of an impact on the predicted label. And we can make a support vector machine using simple pen and paper. So perceptrons are a bit easier. Support vector machines are a bit trickier. So to do that, what we do is we take our data set. These are the 4 points that we have. And what we need to do is to find a line that not only separates, just like a perceptron that separates the points in the two classes, we also want to maximize the margin. We want to have a point that we want to have a line that separates these two at the maximum margin. So we keep on moving this line until that margin bit is maximized. Okay, so if we think about for this particular problem, then this line does not have the maximum margin because this selenite crystal is still too close to particles. But what we can do is we can move it a bit up, and you can probably just tune it like a radio until we are at the location where the maximum margin line occurs. So I welcome you to try to do that. And if you're a bit of a geometry enthusiast, and what you can do is you can determine it simply geometrically as well, right? So what to do that, what you need to do is I'll show you. First, you need to draw a line that connects these 2 points, right? Just like this line that I've just drawn. So I've drawn a line that connects these two, right? So we want to find a line that separates this, right? So what next step I'm going to do is I'm going to draw a perpendicular projection of this point onto this line, right? Okay, so I'm going to try to do that with my selenite crystals. Selenite crystals are great because they also allow you to determine perpendiculars very easily. You can use a ruler if you want. Okay, so this is what you can do. You can now this point over here is the perpendicular projection of this point over onto this. Okay, and the next step we need to do is just to simply draw a bisector of this line over here. So we just need to intercept or cross this line in the middle, right? And to do that, I'm going to use a black pen this time. Okay, so let's do that. And if we go ahead and try to do that, we get this line, right? And that line now is a maximum margin line, or that is the line that the support vector machine is going to give us. So I hope, and just like a support vector, just like a perceptron, if we know the coordinate system for this one, we would be able to find out the equation of this particular line over here. So I welcome you to try this out at your place and show me. You can send me pictures or upload those on Moodle to show me what sort of lines you get. And you can also try out different data sets. What we've done is a very simple and classification problem, but you can also try out other ones. Thank you.